going to talk about the 146 LRU cache. The question is design a data structure that follow the constraint of least recently used cache. So this one is discard least. Okay, so this is the picture, right? Tracking what's the use and when. Okay, so it's okay with the LRU. So this is more detail about what is the least recently used cache. So implement the LRU cache class. LRU cache had this function. We can see here. Initialize LRU cache with a possible size capacity. So this function is to initialize what we need. And for the return, the value of the key is key 6, otherwise return -1. So this one is put, update the value of the key if the key exists, otherwise add the key values paired to the cache. If the number of the key exists, the capacity from these operations, if it is the least recently used key. The function get and put must each run one average time complexity. Okay, so we just only have one example here. The cache initialize, right? Initialize, so this 2 means like capacity. And for this one is put, the cache put 1 and cache put 2 here. And get 1, so return 1. And put 3, key is 2, so in this key, so which means this one is not used, right? So just remove it to replace the 3. Returns 1, something like this. Okay, so for this problems is use the double linked list to solve this problem. So why this needed? Because I need to handle the 2 important things. Because the linked list offer like header, right? This is like I can handle the recently used, and another thing is the not frequently used. Okay, let me do the thing here. Not the frequently used. And for the linked list to double size, it will be good for me to handle the property. So this one is the not frequently used. And this is means the frequently used. I can, like current here, I can use the header. And for here, use the tail to maintain the thing. And header, right? During the header, I can link to the like next node 1, node 2, node n here, and connect to the tail. So every time if I just check for this one, right, N2, so I get it to see whatever, so which means recently used, then N2 will move to here. So which means the head nest always maintain the latest, the frequently. The latest used. And for the tier, I would say tier previous. Not frequently, right? Not frequently. If the size, we also have the capacity. If the capacity is no space, we will move the tier previous. So the high level idea is look like this. So we can write some code here. So we need, what I need is the list node. I need the int key, int value. And also I need to know the previous, this node for the nest. And list node. This value equal to the value. Yep, this is the initialize. So I also need like, what do we need? We should initialize the list node like head, this node tier, right? And also the capacity in capacity. Capacity. How do you spell the capacity? Capacity. And also I need to use like a map integer to cache map to store the node. So if I can get somewhere, I can directly get from the map. That is just to take all one time. So okay, so we can initialize this here. This capacity is equal to the capacity head equal to the new list node. Map equal to the hash map. Okay, so we need to connect the tier. Initialize it should be no this, right? So head nest equal to the tier. And tier the previous equal to the head. Okay, we can keep going to the nest. So we need to implement this get function. Okay, get functions. We need to check list node. Cache map get key. To check whether it exists. If node is not equal to, if equal to none, which means not exist, right? So we can return the -1 directly. Otherwise, if node is not equal to none, so we can this one. Not equal to none, this actually just only have two options. This means not equal to none, and is not equal to none. So what we can do is update recently node. And the last one is update recently node and return to the node value. Okay, so for the update recently, we should move to the head. So it should be remove the node and move to the head. Okay, let's see. So private remove the node. Remove current node is used like we need to cut like original, like we have like this is called like a previous, right, to the node. This is also has like a node has the node previous. This is called node previous, and this is called node nest. So they actually is connected to each other. So what I want is remove the node to connect to the nest. It's like this. So what we need to do is let the previous, right, node previous nest is equal to previous nest is equal to the node nest, and make the node nest previous node nest previous, this one connect to the node previous. Okay, so current now node and nest is already node each other, but we still have the node. Current now is look like a triangle, right? So current now still have the node connect to this one. So I also need to break this node and this node array. So node S break, right? So whatever, this one is okay. So we can put in the void move to head. We can update in here. So head same as this. Current now head, right? Head nest is equal to. So we have to node nest previous equal to the head and node nest is equal to the head nest. Yeah, so we move this one two nodes to connect it to added head here. Now we need to break the head with the original first one. Head nest previous should equal to the head. Should equal to the node, and head nest equal to the order is important. So just make sure you connected the node first to the head, then pick out this one, because we always can find head, so we make sure N1 should be connect to the node first, then do the head. So the order is important. I think this one is finished this part. And now we come here to write the put. Node is equal to the cache map get key. If the node equal to none, right, which means not exists. There's a node, which means node exists. It's not equal to none. So we can start from this one more easier. So node, so we just need to update recently, same. Update recently node, and the node key is equal to the value, right? Okay, this one is finished. Now we come here to check here. Not exists, which means we need to add it. New node is equal to new list node. Now, there has something we didn't use, right? Which is called capacity. So capacity is used here. So if the capacity is smaller than, oh, we need the curve size, right? Yeah, we also need to initialize the current size. That's equal to 0. Oh, this, okay. If curve size is smaller than the capacity, which means we can add it. Else means no space. We need to remove one. So just the node put. We can add it. So cache map put the key and new node curve size plus, and also move to head. Okay, so if not space, we need to move one, right? So is the node last is equal to the tier preview. And we also need to move the map, which is cache map remove last value, or last key. This one, the cache is map curve size minus. And also we need to remove the last one here. Precise part. Okay, so now we have at least one space we can move in. So cache map put new node. Oh, cache map put the key new node curve size plus move to head. Yeah, we can check. So this should be finished. Oops, this head. Yep. wrong answer. Okay, let's see what happened. Okay, so this means cache rate 2, and to put is 2 and 1. 2, 2, and get 2, it should be 2. Oh, okay, I think the value is wrong, right? The key should here. Yeah, this should be great now. Because the current hash should be updated value, not the key. Key is already used for here. So, and for the time complexity is 01 time. This is 01 time, 01 time, and also 01 time, 01 time, 01 time. It satisfies the average time complexity. And thank you.